Hey, welcome back to another Moralis video. My name is Bharat, and in today's video, I'm going to be showing you how you can build your own on-chain score tracker for crypto wallets. So let's get started. So this is what we're going to be building in this tutorial, and as you can see right here, this is a tracker for tracking the on-chain score of any crypto wallets. So you can just paste your address, ENS domain or unstoppable domain here, and what it's going to do is it's going to analyze like a bunch of metrics related to your wallet, basically whether the wallet has interacted with multiple chains, how old is the wallet, how many DeFi protocols has the wallet interacted with, and we'll be seeing all of the metrics soon. So basically, to start with, you can just enter your wallet address right here. I'm just going to put my ENS domain and it's going to fetch the on-chain score. And here you can basically see like what are all the metrics it's tracking, token prices, transaction fees, gas fees I paid, whether my wallet basically has domains. And it's also going to create like a cool transaction heat map, which we'll be seeing soon. So essentially, if you've used Basis on Chain Score application, this is kind of similar to that, wherein you can track the on-chain score for any crypto wallet, and this is again multi-chain. So across all of the chains that Moralis API supports, we are computing the transaction heat map, and we're also computing the on-chain score. And as you can see right here, this is like the wallet summary. So the wallet summary basically tells us, okay, the wallet owns an ENS domain, the wallet owns an unstoppable domain, how many chains has the wallet performed transactions on. In this case, it's basically 6, and then it tells you what are all the chains you have transacted on. And you also get the total transaction count across all of these chains, and that's basically 323. And the chain which has the highest transaction count as well, which you can basically see right here, is Polygon with 161 transactions. It also shows you the first transaction ever which was performed by this wallet, and that transaction date was basically Monday, April 4th, and it basically shows the chain as well. So this is on ETH mainnet, and it also shows us the wallet's age. So the time since the first transaction is basically the wallet's age, and as you can see, it's basically 2.5 years old. You can also see the USD at risk. So basically, if you've seen the previous tutorial on the token approvals API and how you can create your own revoke cache clone, you would know like this particular text is returned from the token approvals API, and that's why we get the total USD at risk. So basically, if I have a lot of open approvals, which uh, which basically have a certain USD value, the total sum of all the USD values of those open approvals is basically the amount shown here. And usually, if you have a lot of open approvals, it's bad for your wallet because your wallet becomes susceptible to risk or smart contract attacks, etc., which would in turn result in you losing the funds. So it's always good to ensure that your wallet has all the smart contracts approvals revoked. So that's the total USD at risk. Then it also shows you the unique DeFi protocols that the wallet has interacted with. And in this case, I've interacted with EtherFi and EigenLayer. And then you can also see the highest DeFi position or the DeFi position with the maximum amount, and that's basically shown here as well. So the highest one is basically a liquidity position with anchor stake ETH on Eigen layer. So I've basically staked some uh, I've provided liquidity to Eigen layer, and the position that I've provided is the anchor stake ETH, and you also get the USD value associated to that. Then you also get the total net worth of the wallet, and it also tells you like on which chain you have the most funds on. So you can basically see the highest funds is on ETH, and this is basically the amount of that. And you can also get to see the total gas fees paid across all of the chains, and you also can see which chain you basically paid the highest gas fees on. And for most people it's basically ETH mainnet. So you can basically see I've paid this much fees on ETH mainnet overall since the wallet inception. So that's essentially the wallet summary. And then you also get this multi-chain transaction heat map. So essentially, the kind of similar to a GitHub contribution map. The darker greens means more activity. So as you can see here on this particular date, I've done 9 transactions on Ethereum and 1 transaction on Avalanche. And then you have like this particular date. Basically, this kind of gives you a rough overview on your wallet usage and your on-chain activity. And basically, more greens indicates that you have used your wallet a lot, you've done a lot of transactions over time, and that's basically reflected over here. And finally, you have the on-chain score right here. So this is my on-chain score. And this on-chain score is actually computed by taking into account all of these uh, metrics. Essentially, if your wallet has an ENS domain, an unstoppable domain, that adds to the on-chain score. And how many chains has the wallet been active on? So more chains equals better. So if your wallet's been active on a lot of chains, that's going to increase your on-chain score. And you also have like the wallet age, so that also influences the on-chain score and the number of transactions. So that's these are all fields which influence that. Then you also have the total USD at risk. So if you have a lot of open approvals, then it's going to bring down your score. Then you have the DeFi activity. So if your wallet's interacted with a lot of DeFi protocols and holds a lot of money in DeFi, then that's kind of showing that it's an experienced crypto user. So that's again going to increase your on-chain score. And finally, you can also see the total gas fees paid, which is basically again shown here. And all these metrics basically contribute towards the on-chain score calculation. So now we can actually get started to understand what are all the APIs that we need for building this. And essentially, we can build our own on-chain score tracker. So before we get started, what I'm going to do is I'm just going to give you a quick overview of Moralis. So if you're aware of Moralis, Moralis is the crypto data platform. And essentially, using Moralis for devs, you'll be able to uh, create any sorts of Web3 applications with ease. And basically, you have direct access to Web3 APIs. And in terms of the Web3 API, you have like the APIs for tokens, NFTs, DeFi, DEX. Essentially, any application that you want to build, you have all the data available to you straight in the form of APIs. And that's what you basically see here, all of the APIs available. So once you've basically signed up to Moralis, you can basically visit this URL, and once you have signed up, you'll basically see your dashboard, and your dashboard shows you like your compute unit usage, your API key, etc. So now you can head to docs, just click on this, and then it'll take you straight to our docs, which is available at docs.moralis.com. So that's on the documentation side. And basically, Web3 data API section is what we actually need for building this, because Web3 data API basically contains APIs across all of the categories. And for building this particular on-chain score demo app, we require a lot of APIs because we need to actually fetch a lot of data. So if your wallet has ENS or Unstoppable, the transacted chains, and then you also have to fetch all of the transactions for a given wallet address, and you have to do it across multiple chains as well. And essentially, this basically means a lot of API calls. So yep, so basically Moralis makes it super easy for you to directly integrate the APIs and get started in building this. Because if you were to build all of this from scratch, you would have to write manual code from to fetch all the data from RPC nodes, and getting all this data in this particular format from RPC nodes is just really complicated. So now to actually build this particular application, you can basically set up your Moralis account, you have your API key, and then you can head to docs. And let's look at like the first API that's needed over here. It's basically for fetching the ENS domain from the address. So if you go into the Web3 API section, go to Wallet API, you have get wallet domains. and this is going to actually have the APIs for ENS and unstoppable domain resolution. And again, it supports reverse resolution as well. So you can fetch back the domain from the address and the address from the domain. So now for this, we're gonna use the get ENS domain by address API. So in this get ENS domain by address, you just paste a given address, and I'm just gonna paste my wallet address, which is right here, and I'm gonna show you how this exactly returns the response. So once you've done that, just take your API key again and paste it here and test live API. So you can see right here that the response basically returns the ENS domain associated to this address. Similarly, we can also get the unstoppable domain associated to the address, and that's basically this particular API. So as you can see right here, you have the resolve address domain. So for this, you can just again paste your address. So yep, and that basically returns my unstoppable domain, as you can see right here. So this is the API that we use for the domain resolution. Then we have basically where we're showing how many chains this wallet has been active on. And as you can see right here, it says that the wallet has performed transactions or has chain activity on 6 chains. So for doing this, we're actually making use of this particular API, and it's basically over here, get wallet details, and then you can go to get chain activity by wallet. And what chain activity by wallet actually returns you is it's going to give me, I'm going to add some chains here, but essentially I have ETH, and I can also add more chains, Polygon. I can then add, let's add Optimism, and then let's add Base, and let's just try calling this API. And as you can see here, you get the response. And for each of these chains, you basically get the first transaction. So the transaction hash of the first ever transaction, the timestamp at which you performed it, and also the last transaction. So what was the last chain that you interacted with? So you get all of this data directly in the form of this particular API call, which is slash wallet slash address slash chains. And in just one API call, you can basically fetch chain activity for a wallet address across like all the chains that Moralis basically supports. And that's what we're doing right here. So we're fetching the chain activity for the wallet across all of the chains. And that basically gives us like what are all the chains the wallet's active on. So that's what you get, the transacted chains. The next one's basically the total transactions. As you can see right here, it gives us like the total transactions across all of the chains that we have actually performed transactions on, and also the highest transaction count chain. So for this particular s- point, we are using the get wallet history API. So if you head to the get wallet history section and then go into get wallet history, you can basically see it right here. And this is like actually one of the best APIs because it gives you like all data for your particular wallet. So you get the full transaction history, which means all the transactions. You also get the ERC20 transfers, you get NFT transfers. So if you're building like wallet portfolio applications, etc., even then you could directly just use this one endpoint and it like speeds up your time to development a lot faster. So for this particular one, I'm just going to paste my wallet address again, and let's run this API. You can see it's still running. So let's just wait for this to complete. So now you can see it's complete. And as you can see right here, this is the data that you get basically from the get wallet history endpoint. And it gives you like all the transaction details. So you have the transaction hash, the nonce, the from address entity. So in case you're basically interacting with big entities like BlackRock, Binance, or any exchange, etc., you can get all that data as well. So entity and labels are basically included in all our API responses. So you basically can get the entity which you're interacting with, the entity logo. So probably an example would be let me try to see if I have a transaction where I've interacted with a well-known entity. So yep, so you can basically see it right here that whenever you have the entity available like Vitalik.eth or Toka Labs over here, it's like a market maker. It gives you the from address entity and also the label. Similarly, the to address is like also shown here, and if in case it's associated to entities, you will also be able to see that. So essentially, whenever you interact with exchanges like Binance or Kraken, etc., you'll be able to see the entity name show up right there. So you can easily filter out what are all the transactions where you've interacted with centralized exchange or decentralized exchange, etc. So this is the get wallet history endpoint. And as you can see right here, we have the to address field, to address label, and the value in case you're sending native token. Value field will basically have some value here. Then the gas you paid for this particular transaction along with the gas price. Then you also get the timestamp at which this transaction was finalized. So which was when it was included in the block. So that's what you see right here. And then you can basically see the block hash, and you also get like all the ERC20 transfer and NFT transfer in case it's basically present for this transaction hash. So for this transaction hash, there's like an ERC20 transfer. That's why it shows up over here. And in this, you can basically see like from my address to another address, what is the transaction that was performed. And you also get like the summary. So whenever you're building like a portfolio, you can just show like this particular summary without creating the summary yourself, because you get it all in this API response. And you also have like other parameters like whether your ERC20 transfer is a possible spam or not. So this comes with inbuilt spam detection. So essentially, if your wallet can get a lot of spam transfers, spam NFT transfers, etc., and like the spam filter basically helps you filter out like tokens which might be spam, and you that's why you have like the security score, etc. So you also have like all this data across all of your transactions, and all of this just available in one API call. So if you look at our on-chain score app, to find the total number of transactions across all chains, what we're doing is we're actually querying the get wallet history across all of the chains that the wallet has actually shown activity on, and then we're getting all the transactions and we're summing the transaction counts. So that's how you're finding the total transactions. And to find the highest, you're also just finding the max out of that. So that's how you can find the total transactions in the total highest transaction count chain. Coming to the first transaction ever. So that again, we can do it with the API that we saw at the beginning. So in terms of that, you basically have the get chain activity. So in that get chain activity endpoint, if you can see right here, it gives us like the first transaction timestamp and the transaction hash. So all we have to do is just find out which is the first timestamp, and that basically gives you the wallet's first transaction timestamp. So it's easy as that for finding that. And you can find the wallet's age by again using that timestamp and finding the age by comparing it to the present date. So that's what we are basically getting right here. Then you can find the total USD at risk from open approvals. And for this one, we're actually going to make use of the token approvals API. So for going into the token approvals, you just have to go into token API and then get token approvals. So this is actually going to return the token approvals for your wallet address across like whichever chain you want. So if I were to paste my wallet address here and run this on the ETH chain, you can basically see what are all the token approvals available. And if you go deeper into the response, you can basically see at what timestamp had you basically approved it, whether it's a possible spam or not, and how much USD is at risk from this approval actually. So actually we have approved this much amount of tokens. this much amount of push tokens, and that USD value of those tokens has again been shown over here. So you directly can see across all of your approvals what's the USD at risk, and that's what we're actually using to compute the total USD at risk. So essentially, if you have a lot of USD at risk, that's bad. You would want to revoke your approvals by going to platforms like Revoke Cash. So over here, to find the total USD at risk, what I'm doing is actually getting the wallet token approvals across all of the chains and finding the total of USD at risk. So that basically gives us the total USD at risk across all the chains. Then you basically have the number of DeFi protocols that the wallet has interacted with. And for this one, we're actually going to make use of the Get DeFi Positions API. So to do that, you can just go into DeFi API right here. And as you can see, we have Get Wallet DeFi Positions. So this is the API that we need, Get DeFi Positions by Wallet. And what this is actually going to do is it's going to return us the DeFi positions on Ethereum, and you can basically get a detailed overview on these DeFi positions as well. So like you can see right here, you get the protocol name, the protocol ID, the logo of the protocol, and what kind of position it is, whether it's a yield position, staking position, or whether it's a liquidity position. All of that basically comes up in this position label. And you can also see the tokens associated to this position right here. So if it's yield position, what's the yield token? So you basically can see that it's the EtherFi liquid token right here, and then you can also see the address and the balance USD. So the balance USD indicates like how much USD is in this particular position. So that's on the balance USD. And if it's like a staking position, typically the staking positions involve claiming the staked amount or the staking rewards. So if it's a staking position, you can also see the unclaimed USD value. That also is really helpful when you're building like DeFi dashboard or showing any DeFi tracker, your wallet data. So essentially, by making use of the total unclaimed USD value, you can get the USD value of all of the DeFi positions, and that's what we're actually doing here. So I'm finding out the total number of DeFi protocols by making use of this particular field, which is the protocol name, and then we're basically finding the total DeFi position amount. So to find the highest DeFi position, we're just actually comparing the values of the total USD value field. And essentially, we're looking at which position has the highest value. And as you can see right here, it gives us like our highest DeFi position is the anchor stake ETH on Eigen layer, amounting to this much amount of dollars. So you have all of that basically present right here, and this is the position actually. As you can see right here, the Eigen layer, and then you can see that this is a liquidity position, and the token that we have staked is actually anchor staked Ether. So we've actually provided the anchor staked Ether token as liquidity to Eigen layer. So essentially, you can see that right here, and you also have the USD value present right here as well. So that's how you can like get the highest DeFi position. The next one's basically on fetching the net worth of a wallet. So essentially, the net worth of the wallet basically means the total value of all the tokens, native tokens, etc., present in the wallet itself. And for this, we basically have the net worth API. So as you can see right here in API reference, you can head straight to wallet API, and then you can go into get wallet net worth. And if you're going to get wallet net worth, this is going to give us like the total net worth of the wallet by accounting for the USD values of all the individual tokens present in the wallet itself. So for finding the total net worth, what we have to actually do is we have to sum up across all of the chains as well. So that's what you see right here. So you can add whichever chains you want over here to fetch the net worth across. So I've just added ETH, Polygon, Optimism. Then we can add Base, and then you have the exclude spam as well, so that we exclude the spam tokens out of this. So then you can just call this API and you can see how the response looks like. So let's call this. Yep. Then you can basically see right here the total net worth across all of the chains is this much. And you also can see for each of the chains how much is the individual value of the tokens which are present. So that's what we're actually doing right here. So we're getting the total net worth, and we're also showing the highest, which chain has the highest funds. So as you can see right here, by comparing like the native token balance plus the token balance, that's going to give you the total value that's present on this particular chain. And to find out like which chain has like the highest funds, we're actually just going to compare the chain which has the highest sum of the native balance and the token balance. As you can see right here, the each chain basically has like the highest token balance, and that's what we basically get right here. So this is for actually for this wallet. So if you want to check for our wallet, we can just paste our wallet address right here, and that's actually going to return us the balance right here. So for ETH, you can see it right here. 1819 plus 165, that gives us the net worth on this particular chain. So you have that right here. And if you want it across all the chains, you have the total net worth USD. That's essentially just summing up all these individual net worth USDs to give you the total net worth. So that's how you can essentially extract the net worth out with the net worth API. And finally, you can basically look at the total gas fees paid. So for this, actually what we're doing is we're using the get wallet history endpoint itself. So if you remember, the get wallet history endpoint is what we used for finding the total number of transactions, finding the chain which has the highest number of transactions. So essentially within get wallet history, the response basically gives us as you can see, it also gives us the gas price, the gas used, and you can also see the transaction fee. The transaction fee field basically contains the transaction fees which or the gas fees that were paid by the wallet in the native token. So since we're on ETH, the transaction fees over here represents 0.0001 ETH for this particular transaction, and 0.014 ETH for this transaction. And depending on whichever chain it is, you will basically get the transaction fee. And by finding the total value of the transaction fees across all the transactions, you get the total gas fees that were paid. And if you were to sum up this across all of the chains, you get the total gas fees paid across all of the chains. So you do have to account for the fact that some chains have different native tokens, like Avalanche has AVAX, Binance Smart Chain has BNB. So when you're finding the total gas fees across all the chains, you have got to multiply the sum total of the transaction fees on that chain multiplied by the USD value of the native token on that chain. So that's going to give you the total gas fees paid across all of the chains. So essentially, this is how you can fetch the wallet summary. And by making use of the get wallet history endpoint, we're also able to make this cool heat map, as you can see right here. And when you hover above each of these, you can see the date and also the chain, along with how many transactions you performed on that chain. So essentially, you can probably see this one. I've done 5 transactions on Ethereum, one on Polygon, one on Avalanche, one on Optimism. So essentially, that gives you all of that data in this cool heat map that you can use to visualize. And finally, in terms of computing the on-chain score, we'll be looking at what are all the metrics that contribute to this on-chain score, and essentially how you can create an algorithm that leverages all of this data to give you like an on-chain score for the wallet. So essentially, to get started now, what we can do is we can create an Express server that our front end's gonna call, and our Express server is actually gonna call all of the APIs that we just went over in order to fetch all the data that we need. So basically, to do that, what you can do is you can just open up your terminal. So if you have your terminal open, you can just create empty folder. So I'm just going to call this express backend onchain dapp, onchain's core dapp. So I just created a folder for our backend repository. So now what you can do is we're going to use express. So we need to first create an empty npm init repository. So you can do that by just doing npm init -y. Once you've done that, you can see it sets up just this basic configs. The next step would be to actually install the necessary packages, and that's going to be express. You can install .env. Then you can also install, let me just see what are the packages that we require. So, yep. So the packages that we require are Axios in order to make the API calls. So I'm just gonna minimize these terminals. Okay, so express.env, then you can basically use Axios. And then we're going to use nodemon because we want to have the server restart whenever we save our files. So I think these are all the packages that we need. You can just do npmi and that's going to install all of it. Cool. So now that it's all installed, what we can actually do is we can just open this up in our code editor of choice. So let me just open this particular repository that we see. So I'm just going to open the folder and where's our on-chain score backend, express backend. That's the file we need. So I'm just going to open this up over here. And what we can do is you can create a server.js file. And that's going to actually contain all of the API routes, your express server, etc. And the controllers, etc. We're going to write this all in just the express in just this server.js file. So to get started. So to get started, you can just import the express library. So you can just do const express equals require express. Once you've done that, the next one would be to actually import Axios to make the API calls to Moralis. So I'm just gonna put in a bunch of require statements, and I'm also going to add the course require, and the .env is for the env file. So if you want to follow along, you can also just look at the code, or else you can look at the description, which basically contains links to the backend repository and the front end repository. So you can directly clone it and follow the env example in that to just get started building it. So now you have to create a .env for this, and this is going to contain like your Moralis API key, and you need to paste your Moralis API key which you get from your Moralis dashboard, which you can see right here. So I'm just going to paste my API key. Once you have done that, the next step is basically to actually initialize your Express server. So you can do that by doing const app equals express, and you can also define the port at which you want your application to run. So I'm just gonna put this, and gonna put 9000 as the port. Then you can just create this middleware function. So we want to use cars in order to ensure that we're able to make requests from our front end to the back end and not bypass the cars policy. And then you can basically enable JSON body parsing. So for that, you can just do express.json. And this is going to ensure that your JSON body, which you get in all the APIs, is parsed. And we can also just create a logger. So I'm just going to create a logger function. This is actually just a middleware function so that whenever we call an API, you can see the API call, the method name, the params, and the timestamp as well. So this is exactly how you can have all the loggers set up. So now to actually have this running, you can basically start the server, and to start it, you have app.listen. So essentially, it's going to point to port, which we've already defined right here, 9000. And to actually start the server, what you can do is you can just open your terminal, and let's do node-mon server.js. Okay, we're getting an issue, so let's see. Okay, we have not installed the cars package, so let's also just install cars. So once we have done that, now we can run the server, and you can basically see the server is running on port 9000. You can verify that by just going to localhost 9000, and that's actually gonna throw you cannot get. So that's basically on setting up your server. Now we can actually write our first route over here for our particular application. So the first route that we require is basically to get the chain activity. So I'm just gonna define that right here. And as you can see, this is basically a post endpoint. So in this particular endpoint, what we're doing is we're making an API call to the Moralis. And as we saw earlier, the get wallet activity, get wallet chain activity endpoint is what we're using to get the chain activity. So you have get chain activity by wallet, and this is actually calling that, and it's getting the response from Moralis. So that's on the get chain activity endpoint. The next thing is basically for getting the DeFi positions. So essentially what we're doing is we're just going to follow the similar format as you see right here. All the API is going to have a slash API slash the uh, action we're trying to accomplish. So then you have get DeFi positions, and get DeFi positions is actually calling the again the DeFi positions API. So get DeFi positions by wallet, and this is actually going to uh, return our DeFi positions for that particular wallet, and that's what you see right here actually. So the next thing is to actually to get the domain data. So for a given wallet address, to get both the uh, unstoppable domain and the ENS domain. So here's a route which helps us achieve that. So you can see we're making an API call to fetch the ENS domain from an address, similarly to fetch the unstoppable domain from the address. So that's what you see right here. The next API would be on getting the profitability summary. If you want to show the PNL for a given wallet address, so you can use the PNL endpoint. So this is actually going to return the wallet's PNL. That's basically this particular API. So let's just wait for this to load. Okay. So essentially the PNL endpoint basically returns you the PNL for that given wallet address. So for that given wallet address, uh, what's the profit and loss, realized profit in USD, you get all of that in just this profitability endpoint. Then we need the get token approvals endpoint. So that's what we are actually going to put here now. So the get token approvals endpoint is actually, as you can see right here, it's calling the approvals, and it's actually going to get all the token approvals. So that's what you get here. Then we have the token price endpoint, and this is required because when you're computing the total gas price across all the chains paid in USD, you would need to query the native tokens in said chain. So if you want to get the AVAX token price, we're going to make use of the wrapped AVAX token on Ethereum to fetch the price. So that's why you have the get token price endpoint right here. Then you basically have the endpoint for getting the transaction history and fees and the gas fees. So that's the endpoint that we are going to create now. And as you can see right here, the get transaction history and fees basically contains the response coming in from the get wallet history endpoint. In case, and since this is a paginated endpoint, we have to recursively call this whenever whenever there's a cursor available. So that's what you see right here. And the while basically ensures it keeps calling it. And for all the transactions, you're basically summing up the gas fee field, which is basically the transaction fee, which represents the fees in the native token. So you get all the transaction fees, all of that straight from this particular endpoint. Then you basically have the net worth endpoint. So essentially, as you saw, to fetch the wallet's net worth, we're going to make use of this particular endpoint. And what this is doing is actually it's just going to call the net worth endpoint. So let's just wait for this to load. We just open this right here. As you can see here, we basically have the get wallet net worth endpoint, and that's what's actually being called right here. So get wallet net worth is actually calling this one to get the net worth across all of the chains that we support. And coming to the next API that we require, the next API is just to resolve the ENS and unstoppable but reverse resolution. So this is basically used to in our homepage. So as you can see right here, so whenever you're coming into the page, we allow the user to pass in their address or ENS or unstoppable domain to get the uh, to basically access this portal. So over here, what we're actually doing is we're doing reverse solution. So if in case the user has an ENS or unstoppable, we can fetch the address, and that's going to be used for all of these APIs. So all the APIs that we saw, like the get wallet net worth, etc., they require us to pass the address. So you would need to ensure that you always have the address. So that's what we actually get by using the reverse resolution API. So that's why we have created the reverse resolution APIs as well. So now we are basically have everything set in terms of the APIs that we need. So what we can do is we can just open up our React app, and I can walk you through the code base of our front end as well. So let me just open up. Here we go. So essentially, this is our React app, and I'm going to start with like the first component. So essentially, this is just using the create React app template. So you can just do a create React app, or you can just clone this repository and then follow the env example to set up your particular uh, application. So what you would need is actually the backend URL within the env, and the Moralis API key is actually contained in the backend. So it helps when you're making requests to your backend. Your backend is actually making the API call to Moralis to get all of the data. So over here, what we're doing is we're just making the API call to our backend, and I'm going to start with the home component. So essentially, this is just showing us like a bunch of things related to what you can do with this app. So you can basically find out your on-chain score. Um, so what I'm going to just do is I'm going to point this to our localhost 9000 so that it points to our instance of uh, of our server. So I'm just going to restart this again. So let's open up this React app, and let's just do npm start again. And what it's going to do is it's going to point to our server that we have hosted, and we can test this basically by opening up the network tab. And what I'm going to do is I'm just going to type in my, okay, looks like we're getting an error. Okay, so the base URL seems to be incorrect. So what we can do is just check this base URL, and let's see. We just need to ensure that the URL is basically pointed correctly over here, and then you should be good to go. So once you have like your URL pointed properly and you have your Express server also running, so I have my server running right here. The next step, we could just test this out by doing entering my ENS domain right here. So once you've entered your ENS domain and click on fetch on scene score, you can see that the request actually succeeded. It's resolved it, and it's calling each of the APIs that we have. and that's basically returning all the responses. So that's essentially how you can see it's making the API calls to our backend and it's computing the on-chain score. So what I'm going to do is I'm just going to go back to our front end now. So you can actually see it right here. So it's actually making the resolve ENS call in order to do the resolution from the ENS to the address so that we could pass it along for all the other APIs. So once the reverse resolution is basically done, in case it's an ENS or whether it's an unstoppable, we're doing the reverse resolution and we're also validating the addresses. So once all the addresses are validated, it takes us on to the next component, which is on-chain score. So in on-chain score, this is what we basically see. At the beginning, we have a couple of loading messages that you see right here, and we have all these state variables that you see over here. So what we need right now for our implementation to go over is the fetch data function, and fetch data basically is where everything happens in terms of getting the data by making calls to our backend, which in turn makes calls to Moralis. So the first one is basically to get the chain activity. So to get all the active chains that the wallet is basically active on, we're using the chain activity function. And what we have done is just to ensure that our code is easily readable, we have split all the extra things that we require, extra APIs that we need to call into services. And that's what you see right here in the services folder. You have like separate services for getting the chain activity, DeFi positions, domain data, profitability, etc. And everything is present right here. So if you go into get chain activity, you can see this is the part where it's making a call to our backend and it's actually getting that. So you can see right here that this is what we're doing. We're actually importing all of the services right here within the main component. So all the get chain activity, token approvals, DeFi positions, net worth, all of it is imported and it's basically used. And if I come back to the fetch data function, you have the first one, which is to get the chain activity, which we saw. And we are actually going to filter out the chains which have active transactions. So if the first transaction field for a given chain is null, it means that the chain, we have not done any transaction on that chain. So we're just trying to find out what are the active chains. So what we're doing is we're just filtering out and we get all the active chains as well. So once you've gotten all the active chains, what you can do is you can again look at the earliest transaction field in the API response of the chains. And essentially, we can compare all of that to find out what was the time we performed the first transaction. Once you have done that, what you can do is you can set the first transaction into our state and calculate the wallet age. So by just subtracting the timestamp between now and the timestamp of the first transaction ever across the chains, you get the wallet's age. So that's how you can essentially get the active chains and do find out the earliest transaction in wallet age, and that's exactly used right here. So to get the transacted chains and to actually find out your first transaction and the wallet age, you're basically making use of this. And the next one's basically for fetching the USD prices. So this is important because we need this for our get wallet history method. So that's what we're doing it beforehand. We're fetching the prices of the tokens. So to get the current price of ETH, Binance BNB token, native token of Binance, and AVAX and Matic, we're just calling the wrap token address of that on Ethereum, and we're basically getting all the price values. So that's what you see happening right here. And once that's done, you have the transaction history and fees. So the transaction history API that we saw earlier, we need to call it for all of the active chains, and that's what's happening right here. For all the active chains, what we're doing is we're calling the get transaction history and fees. And if you remember in our backend, we have it right here, which is get transaction history and fees. It's computing the total transaction fees in the native currency and returning us that. And it's also giving us the transaction timestamp. So you can see it's pushing all the transaction timestamp as well, wherever we have the from address equals to the user address. So that gives you all of the transaction history and fees. And this is just a switch case because we need to ensure that while you compute the total gas fees paid in USD, you want to multiply the chain price in USD for that particular chain. So that's what we're actually computing here for the total fees. So for all the chains which are layer 2s or Ethereum, then you basically make use of the default, which is ETH price in USD. And in case it's Avalanche, Binance, or Polygon, we again multiply by those USD prices. So that's what's happening right here. And to find the transaction count, what we're actually doing is we're getting the length of all the timestamps, because all timestamps is the array that contains all the timestamps, and this is the transaction count on Ethereum on each specific chain. And if you want to get the total transaction count, we just find that by summing all of that individually. So that's how you can use the get transaction history endpoint for what we require. Then the next thing is to basically find out the most active chain. And the most active chain is essentially the chain which has the most number of transactions. So we again determine that by just iterating through our transaction counts object. So that's how you get all of that. Then we can set the favorite chain and this favorite chain transaction count. That's what you see right here. The 323 transactions, the total transactions, and your favorite chain's Polygon, and the total transaction count is what you see right here. So that's how you can essentially get that as well. So to find the total gas fees in USD, we just multiply the gas fees, that is the accumulated transaction fees multiplied by the USD, and you basically get the total gas fees in USD for each chain. And for finding the total gas fees across all chains, you have to sum up over all of that. So that's what's actually happening right here. We're just calling the reduce function in order to reduce over all of our array entries. So once you've done that, you get the total gas fees in USD, and the next one's to actually get the highest fee chain. So here you're just finding the chain where the total fees in USD is the highest. So that gives us like the total gas fees paid. We get this data and how much was the fees paid on the highest chain. So you get all of that data as well right from this. Once you've done that, we're just updating our state, and the next step is to actually check the presence of ENS and Unstoppable. So again, we just have our API already created, which is for getting the ENS and Unstoppable, which we have get domain data right here. So that's what's being called over here in order to get that. And the next one's basically on the net worth API. So you can use the net worth API to get the net worth across all of the chains again. And that's also going to get us all of that. And finally, to get the approval data and the total USD at risk. So what we're doing is we're again making API calls, and we are making is a promise.all in order to actually resolve all the promises parallelly. So that's what you see right here, promise.all of approval promises. And this is to get the DeFi positions. So if you want to fetch the DeFi positions across all the chains that are active, we are just going to call this particular API, and we are manipulating certain things in order to find out the total number of DeFi protocols. So as you can see, we are creating a set. So in order to keep track of what are all the unique DeFi protocols, so that's why you have the set, and all the protocols are inserted onto the set. So you get all the unique protocols that the user has interacted with. So once you've gotten the unique DeFi protocols, the next step is again to use these data, which is the positions data, in order to find the total highest position. So that's what you see right here. The balance USD field, we need to find the protocol with the highest position, and that's actually going to return us the highest DeFi position. So you can find out that right here. So our highest DeFi position is a liquidity position. So you also get the type by just finding out the protocol data dot position. So you can verify this by just going into our DeFi positions API. I'm just going to open this up right here. And you can basically see right here that the position label tells us what kind of position it is. And the token type tells us like whether it's supplied or whether it's a lending or DeFi token, all of that. So that's how you can essentially retrieve this particular data from our DeFi positions API, and we use the promise.all to resolve it across all the chains. So once that is done, the next step is to actually compute the on-chain score. So here comes the main part where we compute the on-chain score. So I'm just gonna open up this page. So you can see our score is shown here as 87.7. So coming to the weightage that we have determined for this, right? So you have it right here. So if you go within the on-chain score here, so what we're doing is actually accounting 40% to transaction activity. So the 40% of your on-chain score is determined by transaction activity. Then you have 25% weightage for the wallet age. Sorry, you have 5% weightage for the wallet age. Then you have 10% weightage for the DeFi engagement, 20% weightage for the net worth, and you have 5% for risk and security, which means if a user has a lot of open token approvals, it means it's going to lower down your overall wallet's on-chain score. And then you have gas fees. So essentially, using the gas fees, we're calculating if the user's gas fees are high, then if the user has contributed a lot in gas fees with respect to their total net worth, then it means they're a active user, and that's what we use over here to compute. And then you have profitability. So if the wallet has a good profitability ratio, it again adds to the wallet score. And finally, domain ownership. So domain ownership is if the user has a lot of domains, it indicates again that they're a long time user and a believer in blockchain. So that essentially is what is determining here. And finally, once we sum up all these values, we get the on-chain score. And we're just again normalizing it to ensure that we are not going above 100. So that's what you get for that's how you can compute the on-chain score right here. So coming into the depth of the computation. First, we're going to start with the transaction activity. So in terms of the transaction activity, what we have is basically the base transaction score followed by the total number of transactions that we have actually performed. So what we're actually doing is we're just dividing the total number of transactions and setting a baseline that, okay, if the user has like more than 250 transactions on their wallet, then it's going to have a high score. And we're also accounting for three things. One is the transaction score. So if a user has done a lot of transactions, second is basically how many diverse number of chains has the wallet interacted with, and trades basically is about how many trades has the wallet basically made in terms of trading activity. So these are the three fields that we use in terms of determining the transaction score. Then you have the wallet age. So for the wallet age score, again, you have the base wallet age score, and the wallet age score is actually computed by using the base wallet age score. And again, what we're doing is actually if the wallet's age is more than 1.5 years, it's going to uh, contribute to a higher wallet, higher on-chain score. So that again is just an indicator of the wallet's age. Then you have the DeFi engagement. So the DeFi engagement, you have a baseline DeFi engagement score, and then you basically have the DeFi protocols. So how many DeFi unique DeFi protocols has this wallet interacted with? That also determines right here. Then you have the net worth. So in case of the net worth, basically what we're doing is if the wallet has a certain net worth greater than a value, it's going to add to a certain score. Then you have the risk and security. If your wallet has a lot of open token approvals, that's going to lead to uh, lower score. So that's what we're actually doing here. And then you have the gas fees by itself. So how proportional the gas fees is to the net worth, that also again is determining the wallet's on-chain score. Then you have profitability. So if the wallet has been making profitable trades, then it basically indicates the user is an experienced trader, etc. So that's also one way of determining the score. Then you have the domain ownership, which again influences the on-chain score as well. So that's essentially the metrics that we look at for determining the on-chain score, and that's what's happening in the fetch data function. So the next one is basically for actually showing the heat map. So you have some auxiliary functions available. So for processing the timestamps into daily counts per chain. So what we have is actually chain results across all the chain. For each chain, we basically have the timestamps, and what we have to do is just process that data in order to basically create a key value pair. And for each date, what we're going to do is we're going to increment the transaction count whenever there is a transaction in the timestamp available. So that's what's happening here, and we're actually incrementing that. So it maps the it essentially within our mapping, it creates the count of transactions for the given day, and it also sets the chain as well. So you have all that available right here. So you can see it right here. And essentially, when a user hovers above that, you're going to get the data available to you in the form of the tooltip, which you see right here. So you can see the chain, the transaction, and the uh, essentially how many number of transactions and the date as well. So that gives you all of that in the form of the tooltip. The next one's basically on getting the net worth and profitability. So basically, to show all this text, we just need to do a little bit of pre-formatting. So we have some helper functions here to help us format that. So this is just formatting the text based on how we need it. And finally, we have the DeFi protocol and push-in data formatting. And finally, you have the HTML, which is being returned. So in terms of the HTML, if you look at it, we have the loader, which is going to be there until the data is basically fetched. Once the on-chain loader has been set to false, then you can see all of the other data. And coming to the other data, here's where we render the heat map. So for the heat map, what we're doing is we're actually making use of a library called React Calendar Heat Map. And what that's actually letting us do is it gives us an easy way to create these kind of cool heat maps like GitHub contribution charts. And with that, we are passing in the start date, which is basically 1 year back from today, and end date is basically today. And you get all the values, which is basically the transaction heat map data that we just extracted by pre-processing it. So once you've gotten the transaction heat map data, that's basically it. Because then what you can do is you can basically have the tooltip, and using the tooltip you will be able to hover above that in order to get whatever data we need. So that's what we are actually just displaying the component right here, and you get the tooltip data attributes and content also specified here, which go into the configs of the heat map itself. So then you have the domain summary. So in terms of the domain, we're showing whether or not the wallet owns the ENS domain, whether or not the wallet owns an unstoppable domain, and basically all the fields you see right uh, here are again just rendered in from the state variables. So all this data becomes available to you, and what you're essentially able to do now is just create this wallet summary for your wallet address. And as you can see right here, uh, for my wallet address, the on-chain score is 87, and we saw how the on-chain score is computed as well. So that's essentially how you can use Moralis APIs to fetch all these on-chain data and build an on-chain scoring application. So I hope you enjoyed this tutorial, and if you did, feel free to share your thoughts. And if you have any questions, feel free to drop it in the comments. You can find the links to both the front end and back end repositories on the description. And feel free to like, share, and subscribe. And I hope to see you in the next tutorial. Thank you.